Okay, this is term 2, week 4, math CA. Very, very easy. Well, I'm just gonna start يعني بسرعة. We have the region bounded by the curve y equal cosine x between the boundaries pi 0, pi over 2, and pi. It's revolved about the x-axis to generate a solid. Which of the following integrals give the expression for the volume? Okay. أول شيء, we don't have two curves, we only have one curve. It's y equals cosine x and the x-axis, okay? When it's graphed for you, it's very easy to determine whether you're going to use the disk method or the washer method. In this case, since it's one curve, it's very, very easy. And we just use volume is equal to pi integral a to b f of x square dx. But there's two choices. Pi can be either inside or outside, okay? Why? Please, if you don't know this, I don't know what to tell you. If you have an integral a times x, it's the same as doing a times integral of x, okay? It's just it's a rule. Like مثلا when you're doing integral ax, مش صح you take the a down multiplied by x to the power of, let's say it's n plus 1 over n plus 1. مش صح, that's the rule for integrating, right? So whenever you have a coefficient, pi is a coefficient, it's not a letter, it's a number. Pi is a number, by the way. You can just take it out. So this pi can be out or it can be in, okay, whatever you want. So these are both correct, because since our curve is cosine x, so it's going to be pi integral from a to b from 0 till pi. It doesn't matter if it's negative. Volume doesn't matter if it's negative, okay, because we're going around. Okay, since you're squaring, there's no negative. Okay, so from 0 to pi, integral of f of x squared, so cosine x square dx. Okay, and if most of you should know, cosine x squared is cosine square x. Okay, so it's just like this. Why is this wrong? Because there's no pi. Why is this wrong? Because they're subtracting for some reason. So, and obviously these two are the only correct ones. Okay, question 2. The shaded region bound by y equal x squared plus 2x plus 5, the x-axis from minus 1 to 2 is revolved about the x-axis. Which of the volume give the expressions for the volume? Again, this is very easy. You only have one curve. They gave you the boundaries from minus 1 to 2. It's easy. Just pi integral from minus 1 to 2. X squared plus 2x plus 5 squared. Right? Dx. I think what's going to be different is the pi. Yes, pi is inside here, pi is outside here. Again, they're both correct, huh? This is wrong because there's no square. This is wrong because there's no pi. Okay? Very easy. Question 3. The shaded region bounded by the curve y is equal to x squared plus 1 from minus 1 to 2 is revolved about the x-axis to generate a solid. Which of the following integrals gives the expression for calculating the volume? Well, these are the same questions over and over again. Again, same thing. We have one curve over here, boundaries from minus 1 till 2. It's pretty much the same question as last time. So pi integral from minus 1 till 2, x squared plus 1 square. Okay, very, very easy. Dx, of course. Huh? Pi can be in or out, like here and like here. Okay, so guys, in my opinion, let's see, is there a fourth one like this? Okay, yeah. So in my opinion, you can take it or leave it. You're gonna get a question guaranteed that looks like this, that says which of the following gives the correct expression for calculating the volume, because you had four questions were about. Yeah, it comes disk method, yeah, it comes washer method, and whatever you want, you can see. Okay, the region bounded by the curve y is equal to x squared plus 3 and the line y equals 7. So we have two curves. From x equals 0 to x equals 2 is revolved about the x-axis to generate a solid. Which of the following gives the expression for calculating the volume of the solid obtained? Okay, so obviously since we have two curves, we need to know which is big R, which is small r. But over here, for the most part, they're all 7 minus something. So I think they're giving you the hint that 7 is big R. But obviously you must be sure in your exam. So you can see here, x squared plus 3 actually looks like this. If you take it on your calculator from 0 till 2, from 0 till 2, it's going to be from here, 2 is over here. It's going to be up at 7 over here. So it's going to look like this. If you take your calculator, okay, imagine this point's like this, okay, and this is over here at 7, and we're revolving around y equals 7, so like this. So this is my two curves. If you take your calculator, you're gonna get this. Just to help show you how it looks when you do it on your calculator, table mode. Okay, start with x squared plus 3. It's very easy, and we're going from 0 to 2. Okay, forget about g of x. No calculator has a g of x function. Like many of the calculators don't have it, from what I've seen. So just skip the g of x that I do. We want from 0 until 2, right? So let's just graph it fast. So over here at 0, it's gonna be at 3. At 1, it's gonna be at 4, and at 2, it's gonna be up here at 7. Okay, very easy. So you can graph it very easily. Okay. And then we said the line y equals 7. And I think all of you know how y equals 7 looks. It's just a horizontal line like this. Okay, so you have two curves. We're going from 0 until 2. Which one's the bigger one? Obviously, y equals 7. So r is y equals 7. And small r is y is equal to, how much is our curve? X squared plus 3, I think. X squared plus 3. Okay, so x squared plus 3. So we can now use our formula. Pi integral from 0 till 2 big R squared, so 7 squared, minus small r squared, x squared plus 3 square dx. Let's check our choices. Here it's 7 minus x squared plus 3, all of that squared. Please don't get fooled. That's very wrong, okay? This is wrong. You can't have it. The square is for each term. 7 square minus x squared plus 3 square dx. That's what we have here with the pi, of course. Absolute value, we never really did anything about absolute value, and I mean, yeah, the absolute value would be correct, but like still the square is outside, so it's wrong. Pi, so here you split it up into two integrals. Pi 7 squared dx minus integral pi x squared plus 3 squared dx. Why is this correct? People are gonna be like, okay, whoa, this does not look anything like what you wrote here. An integral, you can split it up into two parts if you have subtraction. Same way with the sigma r squared minus r, you can split it up into sigma r squared minus sigma r. This integral follows the same rules, and I'm pretty sure everybody should know this. There's no excuse for you not to know this. So it can be split up into this. So pi 0 to 7 squared minus pi integral 0 to 2 x squared plus 3 square dx. So I mean dx, of course, here. You're gonna get this, but here they put the pi inside, which again, like I told you, pi doesn't matter if it's inside or outside, it's the same expression. Okay, so they kept it, they took it inside, which is completely fine. All they did was just cut up this integral into two parts, which is correct. Okay, why is this one wrong here? Here you need to know that big R is y equals 7. Okay, this is why I told you, graph it, make sure you're correct, because here they're using big R as what? X squared plus 3, and that's wrong. Okay. Question 5. The region bounded by the curve y is equal to x squared plus 2 and the line y is equal to 6 from x equals 0 to x equals 2 is revolved around the x-axis to generate a solid. By the way, please pay attention to the question. Many people in the last periodic in the written part did not pay attention to the question and got 0 in the written parts. And I'm speaking for myself, because it's annoying, when you know how to solve the question and you just read it wrong and you solve for x-axis and you end up getting 0 in your written part. But that's not the point. So it's revolved around the x-axis to generate a solid. Just make sure you read it correctly. Which of the following calculates the value? Oh my god, it's the same. These are the same questions over and over again. Same thing. You want to graph it? Let's graph it. Okay, x squared plus 2. You take your calculator. We're going from 0 until 2. So just go take your calculator. X squared plus 2 from 0 till 2. So you have 0, 2. So you start over here at 2. You go up to 3. And you go up to 6. Yeah, 6. Okay, and we have, so we can just connect these. Okay, and then you have the line y equals to 6. Here's 6, we went up to 6. Then the line y equals 6. And as you can see, big R is y equals 6, is our big R. And our small r is obviously the curve, x squared plus 2. Now let's see the formulae. We have, obviously it's going to be pi, integral from 0 till 2, big R squared, so 6 squared, minus x squared plus 2 square, dx. Let's see. This is wrong, obviously, because the square is outside. This is correct, It's what I have written here, just the pi inside, which is completely normal. This one's wrong because the square is outside. This one's wrong because they used x squared plus 2 as the big R. So this one's wrong. And then this one's correct. They just split up the integral into two parts. Okay. Question 6. Speed it up a bit. The region bounded. So these are all just formulas. Y is equal to x cubed and the line y equals 8. From x equals 0 to x equals 2. Generate a solid x-axis. Okay. Again, we're going from x equals 0 to x equals 2. So it would be better to graph it, but it should look something like this. I think y equal 8 should be the big R, but let's just make sure. X cubed from 0 to 2. So 0, 0, 1, 1. So over here, and then 2, 8. It comes like this. Oh, wait. Yeah. Okay, forget about the dot part. I was just checking something. Okay, so this is x cubed, and then he said y equals 8. So 2, we said, is up at 8. So this is over here also at 8. Then he said y equals 8, which is a horizontal line. And we're looking at this region over here from 0 to 2. So the big R is obviously going to be y equals to 8. And small r will be y is equal to x cubed. Okay, so very easy. We can just take a look. Obviously, this is wrong because the square is outside. This is correct. The square, very good. The big R is 8, as we set up. Here, the square is outside. We don't want. Here, they split it up, but they used x cubed as the big R. Here, it's correct because all they did was just split up the integral into two pieces, okay? I didn't write it. خلاص, you guys are familiar with how to write it. Question 7. This came in the periodic. The answer was 26, huh? The answer is 26. But let's do it. The diagram below shows a curve y equals 1 plus 4x to the power of half. And a point A, 2, 3 line on the curve, okay? The line AB intersects the x-axis at B 5, 0. So this is 5, 0. They revolve the solid 360 degrees. People here use the washer method to calculate it in the periodic. And I'm confused. Why I was confused after the exam, when people told me, they were getting this wrong, is because, اجت same exact, عيب, عيب. It came same exact question in the quiz. I told you, pay attention. This looks like it's gonna come. It was so easy, ما بدها هالقد. You just calculate the volume over here. وهيدي you just use the formula that he gave to you. وعادي you just add them. بس لا, people were using washer method. وما بعرف شو. I don't understand that. There's zero reason. I don't understand why people got this wrong last exam. But okay, it happens. خلاص. But anyway, the answer was 26 if it comes again. But why were people using washer method? I still don't understand. I don't know. You have one curve over here, one curve over here. It's just this between the x-axis, يمكن, I don't know, maybe you guys saw that the curve, they said, oh, this is another line over here, خلاص, we're using two curves. No يا عمي, no, not like this. No, مش هيك الموضوع. You use two curves, is that the area enclosed is by two curves, so is هيك. This is two curves. The area between them is in between two curves, this curve and this curve. بس هون, if you look at the area, هون أول شي one curve and the x-axis. هون in this area, one curve and the x-axis. It pissed me off because I felt bad why people were getting it wrong. حرام, it was copy-paste question in the quiz. If you studied the quiz, you should have gotten it correct. But anyway, let me chop. You have over here, we're splitting it up into two parts because here this is a different curve than this. But you can say, wasn't wash method, it's two curves. No, no. Here you have its own volume, and here you have its own volume. Okay? Here it's just one curve and the x-axis. Here it's one curve and the x-axis. Although they are different curves, we're just splitting it up into two parts. Okay? You use this method here, this method for this part. Okay? So for the first volume, the curve is y equals 1 plus 4x to the half. Okay, so we're going to do integral from 0 till 2. Pi outside, of course. 1 plus 4x. 1 plus 4x to the power of half. Square. Obviously, the square cancels with the half. Dx, so you're going to just be left with 1 plus 4x from 0 until 2. Pi. and when you integrate this, you get x plus 2x squared from 0 until 2. So you're gonna get 2 plus 2 times 2 squared, minus 0 obviously, and pi outside. So you're gonna get 8, 4 times 2, 8, 8, 10. Yes, you're gonna get 10 pi. So the first part is 10 pi. How about here? Here, what people did, which is completely correct by the way, is they found, and I told you this in the quiz command, is they found the equation of the curve and they applied the disk method formula, which is completely correct. وأنا أصلا if I were to teach, if I taught a class and I had this question come up, I wouldn't explain this way. Okay, although okay, it's easier, but it just doesn't show your understanding to the concept. Okay, of course in the exam use this. I use this formula. But if I were to see this question for the first time, I would find the equation of the curve first and then apply the formula. But anyway, to find the equation of the curve, it's a line. You can just do y2 minus y1 over x2 minus x1, find the slope, and then just plug in points. You can find the equation of the line very easily and just integrate it, which is a beautiful method. Yeah, I saw people do it. I was happy. But for some reason, they still got it wrong. I don't know how they would get it wrong. Maybe miscalculation. But anyway, if you see this in the exam, use the formula here. 1 over 3 pi r squared h, because when you have a triangle and you revolve it around the x-axis, you're gonna end up getting a cone. Okay, you're gonna end up getting something like this. Alright, so this is a shape. You get a cone if you turn it around the x-axis. Okay, so you can just use the volume of a cone, and the volume of a cone is given to you 1 over 3 pi r squared h. The radius, please, the radius is not this. Okay, it's not this. Oh, let me draw the cone for you again. You're gonna go around, right? So it's gonna look like this. Heck. Okay. What's the radius? Is it this? No, that's the height. The radius is this. This is r, right? So how much is r? It's this. So 3. So r is equal to 3. The height is this, which is from 2 until 5, which is also 3. So in this case, it doesn't matter. But in the exam, it mattered. It was different. I remember it was different. So you use the volume 1 over 3 pi r squared, so 3 squared times 3. So you're going to get 9 pi. Okay, and you add now 9 pi and 10 pi, you get 19 pi units cubed. Question 8. The diagram below shows the graph of two horizontal lines. F of x equals kx squared plus m, where k and m are constants. Point A has coordinates 1, 6, but point B has coordinates 2, 18. Fill in the blanks. They want you to find k and m. Okay, you have to use simultaneous equation. Okay, substitute 1, 6. So 6 is equal to k times 1 squared plus m. So in other words, you can say 6 is equal to k plus m, right? Substitute 18. 18 is equal to k times 2 squared plus m. Therefore, 18 is equal to 4k plus m. You can use any method to solve this. And personally, when I see that you can cancel out two things by subtracting, I just subtract this by this. So I subtract this one by this one. You're gonna get 12. Everything down subtracted by the one up equals 3k. So therefore, k is equal to 4. And then you can go back here. Since k is equal to 4, 6 is equal to 4 plus m. M is equal to 2. These methods both work. This is correct. As well as people using the old way that we used to do. 6 minus k is equal to m. And then you substitute m over here as 6 minus k, which is completely correct. Nothing wrong with that. So now you know k and m. So you know that the function is going to be equal to 4x squared plus 2. And here, this is our function. They want the shaded area. They said that it's rotated around what? The y-axis. And how many questions do we have? 15. Okay. It's rotated around the y-axis. Remember, when you're rotating around the y-axis, you have to rewrite it in terms of y. So take 2 to the other side is going to be y minus 2 equals 4x squared. Divided by 4, you're going to get x squared is equal to y minus 2 over 4. Now put square root both sides. You're going to get x is equal to root y minus 2 over 4. Now let's apply the formula. It's only one curve, the y-axis and one curve. These are just boundaries. Okay, they're boundaries. You're going from here to here. That's not another curve. Okay. Anyway, Uh, we're gonna do the formula now. Pi integral from where to where? We're going from 6 till 18. 6 is over here. 18 is over here. So from 6 till 18. Y minus 2 over 4 root y minus 2 over 4 squared dy. Square cancels with root. So you're gonna be left with pi integral 6 to 18 y minus 2 over 4 dy. Integrate it, you're gonna have y over 4 minus 2 over 4 dy. I just split it up, I split up the fraction so I can integrate. Okay, pi. Y over 4, it's gonna be, you take 1 over 4 to the side, integrate y, it becomes y squared over 2, minus 2 over 4, it's a constant, so you just add a y beside it. We're going from 6 till 18. Let's just clean this up a bit. It's gonna be y squared over 8 minus y over 2, because 2 over 4 is 1 over 2, and just put the y, from 6 till 18, and don't forget the pi. Okay, put this in your calculator. 18 squared, I'll cut 2 when it's done, you get 30, Question 9. Okay, the region bounded below, what is the area? Okay, very easy. Obviously, with area, if it's positive or negative, you split it up. So we're going to do from 0 to 2 first. So x minus x squared over 2. How do you find the area? You do integral dx, and our boundaries, we're going from 0 till 2 first, okay? So 0 till 2. Well, let's integrate this first. You're going to get x squared over 2 minus 1 over 2, take the 1 over 2 to the side, x cubed over 3, right? And our boundaries are from 0 to 2. There's no pi, remember, because we're doing area. So x squared over 2 minus x cubed over 6 from 0 to 2. And you're gonna get, let's see, 4. I think I can do this in my head. 4 minus 8 over 6. 2 minus 1 over 3. You get, hold up. You get 2 over 3 for the first one. Okay? It should be. I mean, let me double check this. I don't wanna, I did it in my head. I don't wanna make a mistake. Minus 8 over 6. Okay, 2 over 3. So for the second one, you're not going from 2 until 3. Why we split it up is because now it's negative, right? So let's do it now from 2 till 3. So we're just gonna copy this, but do it from 2 till 3. Let's do it. It's gonna be 9 over 2 minus 20. I'm just gonna do something like that. I'm not even gonna bother. Wallah. Minus 27 over 6. Okay. And then minus, open bracket, substitute 2 now. 4 over 2 minus 8 over 6. You get minus 2 over 3. And remember, you make it positive, so you get 2 over 3. You add now 2 over 3 and 2 over 3. What do you get? K over 3, which is 4 over 3, right? Beautiful. Question 10. The area of a region enclosed. I know, why do I feel like my mic's off? Okay, no. The area enclosed by x squared and minus 5x plus 6 is what? Okay, you have two curves, you're finding area. Obviously, you have to subtract, but before subtracting, I always like finding my bounds. So I equate them to each other. Okay, so we're gonna get x squared plus 5x minus 6 is equal to 0. And you can factor this 2 and 3 as, 1 and 6, because 6 times 1 is 6, 6 minus 1 is 5. Okay, so you get 6 as the x, plus 6 x minus 1. So my boundaries are negative 6 and positive 1, right? Type. Okay, so we now know our boundaries. We can just do it from negative 6. Remember, the smaller number is always down. From negative 6 until 1, x squared minus, open bracket, minus 5x plus 6 dx. Let's continue. Minus 6, 1, x squared plus 5x minus 6 dx. Integrate x cubed over 3 minus 5x squared over 2. ليه minus قصدي plus 5x squared over 2 minus 6x وحطوها بين minus 6 and 1. Okay, there you can just do it on your calculator. You should get 343 over 6. Let's see. Yeah, so you get minus 343 over 6, which is just 343 over 6. Okay, so k is 343. Question 11. The area enclosed by this, the x-axis, the lines x equals 1, x equals 2 is how much? Okay, like I told you, always you need to check if it ever becomes negative, okay? so you need to check if there's any roots. Let's see, 2x squared plus 2x plus 4, 3 times 4 is 12. Which numbers multiply to get 12? So when you add, get 2. I don't think there is. Why am I factoring? Sorry. Remember when we always check if it has roots, you find the discriminant, which is b squared minus 4ac. And okay, obviously here there's going to be a negative discriminant. 2 squared minus 4 times 3 times 4. Yeah, obviously. So you're going to get 4 minus 4. You're going to get negative 44 as your discriminant. Since there's negative discriminant, معناتها this is always positive, so عادي you can just find the area directly, okay? So let's find our area. We do integral 3x squared plus 2x plus 4 dx, and our boundaries are 1 until 2. Let's integrate this. You're going to get x cubed plus x squared plus 4x. Handwriting is very bad, I'm sorry, huh? From 1 until 2. So you can just do this on your calculator. 2 cubed plus 2 square plus 4 times 2 minus open bracket 1 plus 2 plus 4. 4. Ooh, what was that? 13. Hold up. I know 1 plus 1. Why did I put 1 plus 2? 1 squared is not 2, bro. 1. Okay, I have 14. You get 14 units square. Question 12. The area enclosed by the curve, x-axis, and the line is x equals 4 is how much? Okay, again, check if it's ever negative. I'm gonna tell you there's no c term, so you can factor it, by the way, very easily here. It has roots. It's gonna be 6. Take 6x out, you have x minus 2 inside, so you have x equals 0 and x equals 2 as your roots. So between x equals 0 and x equals 2, it's gonna be negative. But they're saying between the curve, right? Between the curve, the x-axis, and the lines x equals 4. Whenever you have something like this, and they only give you one boundary, I'd prefer you to graph it, okay? It would look way better when you graph. It will just be easier for you, okay? So let's see. From 0 until 4, let's graph 6x squared minus 12x, okay? 6x squared minus 12x. Because many people here, they're only going to see one boundary and they're going to be like, yo, how am I going to solve this? Okay, if I graph it. When you graph it, it's going to make sense. You have 1 minus, it's a negative parabola. No. Okay, 0, 0, 1 minus 6. So 1 is going to be like over here. 2, 0. Okay. Let's continue going. 3, 18, 4, 48. So 3 is going to be up here at 18. 4 is going to be up here at like 48. Okay, so you have something like this. Okay, let's say 4 is over here. Okay, so this is x equals 4. So they want between the curve, the x-axis, and x equals 4. So between these two, so we want what? This shaded area over here. When you graph it, doesn't it make sense? Yes. Then you're going to be like, what's my other boundary? It's over here. 2. How do you know it's 2? That's why you had to do this first step, to figure out the roots. Okay? Usually when they only give you one root, they kind of expect you to find the other root. Okay? And 99% of the time, the other root is just the other boundary, or whatever you want to call it, is always just the root. It's the x-intercept. So obviously, it makes sense. You're going from the curve till 4. When do you start at the x-axis? You start at the root, which is 2. Okay? I'm talking a lot, but my point is, when you only have one boundary, you graph it, try and figure out the other boundary by just finding the root, equate it to 0 and find the root. Okay? Graph it, it's way easier, wallah. Okay? Now you do from 2 to 4, integral from 2 to 4, 6x squared minus 12x dx, and you're going to get 6 over 3x cubed minus 12 over 2x squared from 2 until 4, right? And this becomes 2x cubed, this becomes 6x squared from 2 till 4, and you do it on your calculator. Let's see, I'll put it and whatever. Yeah, so you get 40, very easy, nothing too hard. 13. The curve of equation 5x squared x squared minus 9 is shown below. What's the area between the curve, the x-axis, x equals minus 3, and x equals 3? So here, since it's always negative, You don't really have to split it up because it's always negative. Okay, so some people split it up. You don't have to. Some people find from -3 till 0 and they multiply by 2. Again, that's correct, but there's no, like, how can I say it? There's no clear evidence you have that it's symmetric, so you can't. Don't rely on that. In externals, multiplying by 2 won't work. But anyway, we're gonna integrate from -3 till 3 because it's always negative. You can just add, I'm not sure about this, but I'm pretty sure it's gonna work. Let's check now. Of 5x squared x squared minus 9. Some people be like, oh, how do I integrate this, man? You have to distribute, so it's gonna be 5x to the power 4 minus 45x squared. Very easy. Okay, 5x to the power 4 minus 45x squared dx. So you're gonna get 5 over 5x to the power 5. After you integrate, minus 45 over 3 x cubed from -3 to 3. Cancel. You're gonna get x to the power 5 minus 15 x to the power 3 from -3 till 3. Let's do it on our calculator. 3 to the power 5, pause on. You get negative 324. Obviously, it should be negative because you're going under the x-axis. So make it positive, it becomes 324. Question 14. The area of the region enclosed by these two curves is k, whatever, okay. Obviously, first thing you do, find your bounds. So 2x squared plus 1 is equal to minus 2x plus 1. I'm just going to cancel 1 with 1 fast. 2x squared equals minus 2x. Please don't do this. Please don't do what I'm going to do now, okay? I'm going to show you what not to do. If you do this, in your externals, you're going to get 0. In your CA, you're going to get 0. In your periodic, you're going to get 0. It's not math, okay? 2x squared equals minus 2x. What people do, they divide by x on both sides. Who said you can divide by x? No, never do this. Never do this, okay? Don't. It's not allowed. It's not, okay? When you're solving an equation for x, you don't divide by x because you have an x squared term, which means there's two possible values, right? X squared means two possible values for x. So now, when you're coming and you're dividing by x on both sides, you're going to be left with 2x is equal to minus 2. You're left with one possible term for x. It's not math. You can't do this, okay? Even though many people think, oh, عادي, I'm just dividing by a common factor. No, you can't just reduce the power هيك, okay? So, what was I saying? 2x squared is equal to minus 2x. You solve it as a quadratic. You take minus 2x over here. It becomes 2x squared plus 2x is equal to 0. Now you can factor out 2x and you'll be left with x plus 1 is equal to 0. Hello, you get x is equal to 0 and x is equal to negative 1. Okay? This is how you solve a quadratic. You move everything to one side. That's how you solve a quadratic. Nowhere did I ever explain on my YouTube channel to solve a quadratic, you equate it to each other and divide by x on both sides. Never did I ever. Every time I solve a quadratic, I take it all to one side. Okay? Hello. Most people will solve it the correct way, but I'm sure 100% there's gonna be somebody who's trying to act smart and divide by x on both sides. Okay, don't do this. Anyway, you have x equals 0 and x equals minus 1. So our boundaries are from minus 1 to 0. And 2x squared plus 1 minus open bracket minus 2x plus 1 dx. So you should get integral from minus 1 to 0, 2x squared. The 1 with the 1 cancels, 1 minus 1. And then minus 2x becomes plus 2x. dx. Okay, integrate this, you can get 2 over 3x cubed plus x squared. I'm just doing the integration a bit fast. Let's do it now. 0, and then obviously 0 will get you nothing. So you're just going to put minus open bracket, because the 0 gets you 0, right? So 0 minus open bracket. Substitute minus 1, 2 over 3 into minus 1. I should put times. 2 over 3 times minus 1. Why didn't I put cube? Because it's the same thing. And I'll put 3. This is the same thing. Plus minus 1 squared. Here you actually have to put the square. So you get minus 1 over 3. Make it positive 1 over 3. Okay? Question 15. The region bounded by the curve y is equal to minus x squared plus 2 from y, and the line y equals 1. So you have two curves, two y lines. From x equals 0 to x equals 1 is revolved around the x-axis to generate a solid. What is the volume of the solid? Okay, they gave you the boundaries, they gave you the two curves. You just need to know which one's big R, which one's small r. How do we do it? Graph. Okay, so we have our graph from 0 till 1. Like it's 2 points. 2 points. If you can't take 2 minutes out of your sweet time to put into your calculator two graphs from 2 points, then in my opinion you shouldn't be doing 11s math. It should take you 1 second, okay, and not even 1 second, even 30 seconds, okay. You're going from 0 till 1, so from 0 till 1, so you have 0 comma 2 and then 1 comma 1 over here. Okay, so it kind of looks like this. Okay, and then the line y equals 1, we know this is at 1, right? This point is at 1. Y equals 1 is just a horizontal line passing through here. So which one's big R? It's the curve. So the big R is the curve minus x squared plus 2. Which one's small r? Obviously y is equal to 1. So now we can do our formula. Integral from 0 till 1. Big R squared, so minus x squared plus 2 squared minus 1 square dx. We actually have to do this. So minus x squared plus 2, you use the rule a minus b squared. Why a minus b squared? People say it's a plus b, but it's because you have negative x squared. So it's the same thing as saying 2 minus x squared squared. So isn't this a minus b? Yes. Okay, so when you have a negative, you have to use a minus b squared. So we're going to start 0 to 1. A squared is going to be x to the power 4. Minus 2ab, so minus 2 times x squared. Plus b squared, so plus 4 minus 1 squared. Please keep in mind, when we're using the identities a plus b squared and a minus b squared, the reason we have a separate identity called a minus b squared is so that the middle term will be negative, okay? This is why you don't account for the sign, okay? You don't account for the sign. The sign only tells you which identity you should use, okay? Some people, they don't even use the identities, they just expand it, like they solve like this, which is completely correct, like adi. But no, in my opinion, no, it will save you a lot of time knowing the identity. It's 2 seconds. They solve like this and they distribute. This is completely normal. So anyway, let's continue from 0 to 1, x to the power 4 minus 4x squared. 4 minus 1 is 3, huh? So plus 3 dx. Integrate, so you're getting at x to the power 5 over 5 minus 4 over 3x to the power 3 plus 3x in between 0 till 1. Okay. I'll put it in a calculator and pi outside. Oh, I forgot about the pi. Pi, and pi. So you get over here 28 over 15. So the volume is 28 over 15 pi. So k is 28. Thank you so much for watching and good luck in your CA.